Um, hello, hello,
Hi.
hello,
Hello.
hi,
Hello.
hello. Hello. Good to see you, and good to see so many videos. But I know you're not seeing mine. I'm trying to fix that. I don't know why. Hold on 1 second. Let me see if. Let me see why that's happening. But hello, hello. Maybe. Does that help at all? Wait, I don't know what's.
We
I'm
can
on
see
two.
you in the corner.
Right. Okay, this is awkward to say the least. Okay, hold on. We're letting everybody in. So I'm not on my computer. I'm not on my normal computer. I'm on two devices. One is my normal tablet, which is what I'm trying to talk on right now. Um, one is my normal tablet for doing all the screen share, all the whiteboard. The thing that I'm actually zooming from is not my computer. My computer has broken. It is supposedly being fixed. So for some reason, the thing that I'm talking on, that I want to talk on, is not showing video anyway. So this is annoying and awkward, especially since I make such a big deal about video, and I realize that. All right. Well, hello. Okay, I'm going to do. I don't know how to use. So this device that I'm on, I don't know how to. It's like a Kindle Fire that the store lent me. So it's not really equipped for this. What we're going to do is get rolling in a hot second. Uh, good afternoon. All right, I'll say good. Hello. Okay, I can see that. That's good. Hello, Stephanie, and good afternoon, Jenna. I see that, and I certainly see Jenna, and I see Maria, and Katie, and Eric, and Cheyenne, Shy. Good afternoon, and Paulina, and Emily, and Logan. Good afternoon, everybody. You look about as excited as I. And Mohammed. Good afternoon, Claudia. Sorry. Good afternoon, Josephine. Good afternoon, Jada. Good afternoon, and Shy. Okay. And also Alexis, Shawnee, Emily, Brandon, Victoria. Good afternoon, Logan. I think I said Stephanie. I think I said. Okay, I'm sorry about this. Is all very awkward and weird. We're just gonna get going in a second. And we're gonna just keep going over. And this is at least recording. I don't even know if that's good, but we are recording. So if this all gets weird, you can at least, you know. But what we mainly want to do is continue going over homework one. Well, let me catch up. And as soon as we start going over this, as soon as I switch the screen shares, mostly you'll be looking at the whiteboard. And I apologize if you also can't. Normally you would also see my face, but it doesn't do much good anyway. But I think my face is going to disappear once I do the whiteboard thing, or it's already disappeared. Okay, I'll just say homework one, number line, which we're going to continue going over today and hopefully finish. Homework one, I'm very pleased, very, very pleased. A ton of you submitted a draft, then you got, and if you submitted on time, you got like a 15 or whatever. Then you saw, well, hopefully it's clear that anybody who submitted a draft last week and got a 15 or something like that just for submitting it on time and thoroughly, then eventually at some point this weekend got a bunch of feedback on it, hopefully. And then a bunch of those people already have gotten the feedback, turned it around, and submitted another draft. Of course, that's not required. And if you, it's not required, and it's not required that you did it that fast, but it's excellent. It's totally excellent. And those of you who still want to submit a draft, another revision, totally fine. Totally fine. There's no clock that's going to end on that. If you, the quick summary of, so we're going to go over it now. If I would say if you got a 19, or if you got a 19 on it, I would, now homework is already started piling up. You have a bunch of other things that were due today that of course I saw all of those. I started reading some of those, but they were technically due today as far as I know, like the average speed and the train of thought. So I certainly haven't gotten back yet. But there's a new one that's due. Oh God, this whole video is so weird. I don't know what's happening. Oh, okay. Oh, and there's a question. All right, I've got a question in a second. Sorry. And I really do apologize. I'm totally out of sorts because of not having a computer. So I'm not managing this well at all. But I see a hand. I'll get the hand in a second. I will try to figure out how to do the chat on this. I'll get that in a second. But what I'm trying to say is all the homework, there is a new homework that will start getting hard. It's not due on Monday, it's due Wednesday. You have a week to do it because I have to sort of myself, and with you guys here, someone's here. We have starting to get into the material now. It'll start piling up. You will get a break from homework at some point soon so that we can all catch up, but just keep trying your best. You'll notice it's getting harder. Just try to do what you can do, and just remember also that revisions can always be uploaded, grades can always go up, and as long as the portal's there, as long as you see a portal for a given homework, that means I haven't taken it down. It means I'm still accepting new attempts and hiring more people here. On this first one, I know this is ridiculous. I don't know if you can see anything. You can sort of see me now. Okay. On this first one, this is really confusing. I don't even know what I'm looking at, but okay. On this first one, if you got a 19 or a 20, you should congratulate yourself and you should put it to rest. Like, I don't think you can redo it if you want from a 19 to a 20. I hardly think that's worth it at this point with the other work that's piled up, but you're welcome to. But I think if you got a 19 or a 20, I would make sure you know why it is you got a 19. Make sure you know what it is that I'm still asking for so that you can do it on future assignments and know it for the exam. That's really the point. But I would be, but don't overstress it if you got a 19 or a 20. If you got a 16, that was a pretty common score. If you got a 16, that's still a perfectly great grade. It really is. It's a lot of points, and if you got 16s on if you got that amount out of whatever was allotted, for the rest, you're doing fine, more than fine in the course. But since we're at the beginning and we're trying to figure out what's expected and what we need to do for the exams and stuff like that, I will admit, or I will clarify, that if you got a 16, it probably means I went through the whole thing. Hopefully, I gave you feedback. Hopefully, you can read my handwriting. And it probably means, yes, it's totally respectable. Like, you did a lot, and you did a lot, and you're totally a good student, and we're on the same page, and you're on time and all that. But probably, if you got a 16, it does mean, okay, I gave one more point for the fact that now that I've read through it and see all the content, but actually there's probably some big steps missing repeatedly throughout. It probably means you got a lot of right answers, probably. And you might even be confused that you didn't get a 20. But probably if you got a 16, it means maybe repeatedly over, or in general, you're not remembering to do step 2, which is state the question clearly right after step 1 and before you do anything else. That step annoys everybody at the beginning of the semester. People don't like it. I understand that. We can have a talk about it at another time, but it is the one that really turns out to be super important and really help with hard problems, and it gets left out a lot at the beginning of the semester. So and same thing with step 3, GDP. It's not the same as what the facts are of the problem. We'll get more used to it, but just so you know, if you got a 16, probably there are things like that you want to start focusing on, and you can still revise. Last thing, I know I'm talking into the wind here. Last thing, or 2 more sort of acronyms to teach you, in terms of reading my handwriting on homeworks and exams. You might want to jot this down, especially because clearly I'm not jotting anything down. You might want to jot down, number 1, if I ever say if I write BCF, like capital B, capital C, capital F, that's not a step that you're missing or anything like that. That is not a specific step, but it just means be careful. I don't know where that came from, but just know that means be careful. If I ever write WWW, that's not a step either, but that's a little bit of a big deal. And I don't think it's happened yet, actually, on any of your homeworks, but it does happen on exams. If I write WWW question mark, what that means is, well, what in short it means is, what is this? Why is this true? Where is this from? And let me say now, while we're still all safe, because it hasn't really happened yet. If ever I write WWW, especially on an exam, that's kind of a polite or gentle way of pointing out that I think you've written down some physics. Sorry, I know you still can't see. If I write www, it means I think you've written down some physics that might be correct, maybe, like maybe an equation or something like that. It might be correct, but it seems a little out of left field to me. Like it doesn't look like physics that we've talked about yet, or it doesn't look like physics that we've talked about in this context. And basically it means like it seems like it's physics from the web. Okay, now you are allowed to go on the web all the time. You're allowed to use any resources you want all the time, but the point of using resources is to get help, to get clarity on things, and then thereby understand them better. By the time you write something down on a piece of paper, it has to make sense to you. Like you have to understand it, and it has to follow logically from everything else you're writing. So basically, if I write www, that means I think that's a leap that you just made, like that just came out of nowhere. And I'm not totally confident that you know what you just wrote, or that it has anything to do with what we're doing right now, or what logical thought process you were just putting down. And that you want to be really careful of on exams. Okay, so that hasn't happened yet. That's why I'm saying it now before anybody can be worried. Okay, last thing. I'm just thinking about notes that I made on the homework. And they were really good. And sorry, and I know this is a weird class, but the homeworks I think everybody is very on top of. And again, if you already turned in homework 2 and 3, you're on time, you're good, but technically they were just due. So I don't have feedback for you on that yet. Last thing. Step 5, final answer circled. Also very important, also sounds very silly and kindergartenish, I know. And it's not that it has to be circled, it could be bold-faced, it could be highlighted, it could be, it could be other things. But it has to be really clear that you know when you've landed on an answer. That's really actually important for research and everything else. It has to be clear that you know the information you've written down is not just important, but is the information we're looking for. That it's the information that ties back to the original question in step 2. Like there should be a very clear closed path, so to speak, a very clear, closed path, like a loop between step 2 and step 5. Step 2 lays out a question, step 5 answers it. And that means, last thing, this is something that if I ever write on your paper or somewhere, FAC, and then I put an equal sign afterwards, or something like that, what I'm getting at is your final answer has to be an answer to the question, which means it has to be a complete thought. It has to be a complete thought, a complete statement, which in physics or in math means it's an equation. And I want you to, and that's important on a ton of reasons. Again, I know that for some of you, it seems like a boring insult to your intelligence at this point. Some of you, it's not meant that way at all. But what I'm saying is, if the question asks, what is the average velocity between t equals 2 and t equals 7? If that's the question, between t equals 2 and t equals 7, what is the average velocity? Then the final answer in step 5 has to be something of the form, between t equals 2 and t equals 7, average velocity, like v with a line over it, which we'll talk about today, average velocity, like v with a line over it, equals, double equal sign, 37 meters per second, or whatever. Like your final answer has to be an equation, not a formula, not a definition, an equation that states this quantity measurement has that value under these conditions. Like, again, try to just think in the back of your mind that all of these homework, granted they're exercises, granted they're annoying, like they're just between you and me, but they're all supposed to be representations or practices for what like actual science research would be. So you're trying to figure out something under a set of conditions, and then you figure it out and you state it. Like you state what it is. And again, the litmus test always is, can I follow what you're doing? Or can someone who knows physics follow what you're doing, even if they don't have any other documents in front of them? Like you are writing a journal article in effect, maybe not a fascinatingly original one, maybe it is, but you're writing a journal article I could just read and learn physics from. Like that's the point. Okay, that's enough of that. Sorry, I know this is all awkward and weird. So I'm going to go, I'm sorry, Josephine, you've had a question for 49 years. I'm sorry, Josephine, go.
It's okay. I was wondering. Oh, I'm like right up on the screen.
I was just wondering if I could submit those 2 homeworks late. I didn't realize that those were up there because I'm still getting used to Google Classroom. Is it possible to turn those in late?
Oh yeah, wait. So yes. So the simple answer is yeah. I mean, sorry. The short answer is yes, absolutely. The second answer is thank you for having the guts to ask that for the sake of it. I'm sure you're not the only one who's wondering about that. In fact, I know for a fact you're not. Thank you for asking that. Thank you for asking it with your video and with voice. I know this is all awkward. You don't forget to submit for tons of points for the fact, like literally, you can just triple dip for the fact that you just asked that. Really. And all of you, I hope you see if I ever write double dip or triple dip on your game turns, that's a good thing, not a bad thing. That and if you want more clarity, what I mean by that, like I'll say it again later, like in the chat or you can text me. But if I ever say double dip or triple dip, that's my way of saying like you actually just indicated a way in which you deserve points all over the place. So okay, which Josephine just did. Okay, so the answer is yes, yes, yes. We are still at a state with everybody handing in homework like on time or early is a good thing, and it's a noticed thing. Those of you who did do it, don't think that it went. Don't think that you're not being noticed in the universe or by me, or something like that. Also, right, but nonetheless, right now, I want the homework to be done. Not only is it better late than never, but to be totally blunt, is Josephine gets her homework in, eventually, even if she doesn't do it perfect, and then she does a revision and she gets it perfect, she'll get all the credit on it for right now. And someone else who turns it in late will eventually get the credit too. Those of you who turned it early, I want you to know, if you're thinking, well, wait, then what was the point of me killing myself to turn it in? And I'm not saying this to slight Josephine either. I'm just saying this is the balance in the class. Everybody has a chance to do really well in this class, especially at the beginning. Lesser imperfect things right now are not to be shamed or punished, but better things, I mean, and I hope Josephine does take this the right way, or everybody does, better things can nonetheless still be rewarded. Those of you who did if you killed yourself to get it on time, don't think your efforts are going unnoticed. First of all, I know that you did. It's all date time stamped and all of that. Sorry. So like I'm aware of those of you who did get it in on time, and some of them I had started marking already. But second of all, also just to be really blunt, it's like the difference, honestly, between like natural life, real. I hate this word actually. I don't even want to use it. It's the difference between like natural life and weird reward punishment contrived systems. And that is just to say, what's going to stop Josephine from turning her homework late every single time? The fact that she's the kind of person that just asked, the fact that she's the kind of person that's concerned about it and just had the guts to ask, first of all, is already an indication that she doesn't feel like totally psyched to be she even said she didn't notice it on her Google Class or whatever. Like, she's not going to do this every time. And really bluntly, to everybody, not to Josephine, to everybody, we all know the real disincentive after pretty soon. Once I'm going to get rolling here, I promise. But the homework's going to pile up enough that it's just going to make it harder for you guys like to not stay on top of it. That's the real incentive to stay on top, is to stay on top and then understand class more and better and participate in more, which Josephine totally does. So to everybody, if you've missed a beat at this stage, you have not missed it permanently. Everybody can still do everything, and you can still submit infinite revisions, and everybody can still get full credit until I say otherwise, and there will be that point. But okay, I hope that answers. I don't know, that's a lot. I'm going to start now. Let me just see. I don't know if I can read the chat. I don't know if I can find the chat. This is so annoying. But I'm going to start just like doing the notes, going over homework 1, which will be more just direct and straightforward. But I'm just looking if there's something in the chat. I don't know it. Wait, can I see the chat? Oh, chat, there is something. Oh, there's a lot in the chat. All right, hold on. Oh, okay. And now I see the chat. Oh my God. All right, there's a lot. All right. So hold on. Let me just. And I know this is awkward. Maybe someone put in the chat too at some point. Like, I know this is I'm not liking this at all, this whole video format here today. I'm not proud of it, but I'm assuming you can hear me and that this is functioning okay, like serviceably. Let me know if it's really a disaster. Okay, so I'm looking in the chat. Good afternoon. Good afternoon. Good afternoon. Some were confusing. I don't know if. Wait, 3 was due before 2? Is that true? If that's true, that was a total accident. Wait. Oh, okay. Hold on. Two new quick points then, or two. I didn't mean to. Did I make 3 do before 2? If I did that, I apologize. And that was not. I'm trying to get in the video again. If I, oh, I don't know if that helped. If I did 2 before 3, I mean, if I did, I apologize. I'm not. Okay, and I'll look. There's more in the chat, but let me also say again with 2 and 3, if 2 is average speed, which I feel really comes next, average speed, that it's short but not easy. I mean, the questions are tricky eventually on that sheet. Like it might be easy to do, but I have to admit, like the last 2 questions on the average speed sheet are easy to do. Maybe I should never say easy. They're straightforward to do, but they're very straight. It's very likely, it's very easy to get them wrong. That's for sheet number 2. You definitely need to and want to do the 5-step method. Sheet number 2, whatever sheet is average speed, that's traditional physics. We're going to talk about it a lot once we get to it. You need to do the 5-step method for that. Like those are almost like exam problems at that point. The train of thought is, I'm sure, very confusing to a lot of people. Train of thought is like is off to the side. It's super important once we talk about it, and it's meant to be talked about. It's meant to be talked about. And as long as you did it, or you will get full credit on it. It's not about right and wrong, and it's not. The train of thought is not about the 5-step method. It's like the one homework like ever, I think, where, and I think it specifically says in Google Classroom, don't worry about the 5-step method for train of thought, just do it. Maybe even relax and have fun with it, because it's not about right or wrong. Like, I mean, there are right or wrong answers, but I don't care what you think is right or wrong. I shouldn't say that either. You know what I mean? You're getting full credit for it, no matter what you think at first when you do that. Just give it your best shot and really almost just relax and have fun with it. If there are things confusing about it, you can leave them blank, or you can make a note and ask in class. We will talk about it. It's very important, but it's very conceptual. It's not numerical or mathematical, as you can see. It's like when we talk about it, you'll understand it better. So don't stress train of thought. If you're going to stress anything, I would say stress average speed. So, and if you haven't done one of them or something confusing, yes, you could still do it, like Josephine asked. And then we'll catch up with ourselves. And then the 4th one, which is really real and really like an exam kind of thing, that would seem impossible if you opened it up right now to almost any of us. I totally understand that. We'll have time, and if I have to extend it further, maybe I will. But right now, it's not due Monday, it's due Wednesday. We'll have time to talk about more things before we get there. If you have handwriting okay, I'm looking at the chat again. If you have handwriting questions, obviously text me or like send me a screenshot, or if there's a lot of them, we can make a quick phone appointment or Zoom appointment or whatever. But of course, I don't mean to make the if you can't read handwriting, you can ask me about it, and I'll definitely. And so on Jenna's question, right now there's no time. Right now, there's no time limit to redo work. If I get to the point at some point where I say, like, I think we're done with homework 1, let's all put it to bed, then I'll announce that, and maybe I'll even like shut down the portal or something. But as far as I want you to be concerned right now, it's infinity. I want you to just get that. The whole idea is to, even if you don't love the method, to understand it enough so that you feel like by the time we take an exam, you'll know what's expected. So there's no time limit right now. Okay. Oh, he said no. Okay. Thank you, Shawnee. And those of you who are collaborating with each other in the chat, like Shawnee's answering Jenna's question, and I think I saw somewhere that Nancy like affirmed. I totally now forgot. Yeah, sorry, that Nancy affirmed Josephine's question. Please, you guys, like submit those for points in multiplayer co-op. I know it all seems silly, but at the end of the day, it's not. It's because if we don't make physics somewhat like that, then it can be really dry and whole torturous. Okay, all right. So awesome, Jenna. But I would work on it soon for an exam. Right, like Shawnee said, right. As long as you have access to the link, you can resubmit. Right, Katie, thank you. Yes, exactly. Hi, Christina, awesome. Thank you, Nancy, for thanking Josephine, awesome. Thank you, Paulina, for thanking Nancy, for thanking Josephine. Oh, I got to make like a 3-way multiplayer co-op at some point. That's hilarious. Okay, I mean in a good way. That's all. Okay. Mine will do at the same time. Oh, okay, so maybe, okay, thank you, Paulina, for clarifying that, because Yeah, I mean, I'm sure there's legitimate confusion, but yes, I didn't think I'd done. Okay, cool. All right, fine. Oh, okay. And we're gonna go on now, but thank you. Okay, that's a good point from Maria. That's very clarifying what Maria is writing in the chat. Like, yes, yes, yes. That is true. In the classroom materials. Now, this is actually I mean, I could change this. It's not, I mean, but I feel like it's the right thing to do. I mean, not in the materials, in the classroom, in Google Classroom classwork. Under homework, what I do tend to do is stack them. I tend to put the thing that's due most recently up on top because like that I think is like what you're focused on right now, or I want you to be acutely aware of whatever just most recently got assigned. So they're stacked that way, like what Maria's saying. I mean, the only thing I do have to admit to Maria and everybody else is that's something I mean, that's not like Google's fault. Like I could change that. Maybe I should if it's confusing to people. But yes, that is what I tend to do. Okay, so this is good. I hope that answered all the questions in the chat. You can keep, now I know where the chat is. You can keep it going. Sorry that I'm all right. So now I'm going to go to the board. Hopefully that'll make this class clearer when are you seeing the board? Oh my God. You're not even seeing the board, are you? You have a board? So it's not showing. Oh, yeah. Hold on. This is hold on. Okay. So now share. Okay, that's a start. So you can see.
Professor, can I ask a question?
Yes. Oh, can I just say? Yes, you can. Yes.
Oh, okay. So for the train of, I highlighted the key points and then I paraphrased what those key points are because you just asked us, are we moving? Is that okay? Because that's what I submitted.
No, that's great. That's great. On the train of thought, yes, it's great. Any way you do it, I'm not strict about the formatting on train of thought. The truth is, any way you could do it that you could almost a little bit relax and have fun with it, as long as you understand what I'm asking, would be great. Yes, that's fine. And you'll get, as long as you did it and it's sort of clear what you were doing, you'll get full credit on it. Yes, that's fine. That's good. All right, thank you for asking. Oh, okay. Oh, cool. Thank you, Claudia. Okay. Yeah, I mean, and honestly, okay, and I'm gonna thank you, Claudia. And honestly, once we talk about it, I am hoping that more people, maybe in retrospect, like it. Like it is meant to be fun. And the truth is, when we talk about it, we'll talk about it. Like it's meant to get our thinking in a certain direction for it's well, whatever. We'll talk about it when we talk about it. But yes, it is meant to be fun. It just can be very not fun for people because it seems unexpected and different from everything we've been like trying to figure out otherwise. So it seems it can be jostling. I understand that to people or confusing or but yes, I'm glad. If Claudia thought it was fun, ultimately it is meant to be fun. And it's if nothing else, what physics, I'll say this too really quickly too, and not to it's really meant to remind everybody, even though we're going to get all caught up in the weeds of all this mathematics and all these symbols and all these equations, for sure, like eventually physics becomes very symbolic and very equation driven, very mathematical, you could say. The truth is that the heart of physics, the actual thing that makes physics what it is, whether that means interesting and fun or hard or both, the heart of physics is not the math. Math is just the language of physics. The thing we always have to think about in physics is the physics, which means the space, time, the language of space and time. So train of thought, and for some of you, that might be more of a relief when you're thinking about stuff like that rather than the math. So anyway, whatever. But I'm glad that Claudia said that. Okay, and you should definitely put that in a game turn. I need a new portal for that too, I think. All right. Can I just get a confirmation of some kind? I know I have like, can you, that's not what I meant to do. Wait. Okay. Can you see the whiteboard with, there's something, I don't even know how I would know if you could. This device is so.
I see the one with the V, the mean of volume is equal
right.
to X
Yes.
minus X over the initial
Awesome.
and then time.
Awesome. And you can see it and you say, yes. Okay, great. All right. And Hopefully you can make it as big as you need to, and hopefully in the recording it will be big. That I don't know at this point, but all right, here we go. So on the way. So I'm gonna, now again, as always, those are supposed to be equations that we're going to talk about today. I know I have not actually technically introduced either of those equations yet. Well, I mean, one is an equation and one's sort of a note to the wise. But let's just dive in here. Okay. I believe we're on question 2. Okay. Okay. And he goes like this. I know, I'm just repeating. And you're gonna have to, I always forget. I think it's 3 seconds and 2 seconds and 3 seconds. Somebody maybe remind me. And they're all constant speed, of course, but I think this is right. Okay. Okay. All right. So question 2, or tell me from, yeah, I think I could tell if you were telling me if I was wrong. I think that's all right. All right.
Yeah, those are right.
Oh, thank you. Great. Oh, and thank you. And oh, that's a video. That's a person. That's awesome. So, oh, now you're all big. Sorry. Okay. Thank you very much. Okay. But I don't know who, sorry. It usually says the name on the thing. Tell me your name again. I'm sorry.
It was Paulina.
Paulina. Great. Thank you, Paulina. I really appreciate it. Okay. Great. Okay. So question 2. All right. And notice, I'll just to be practicing here, all of what I just did was a repeat of step 1, right? This is all DFP. If I ever write DFP on your homework or on your exam, I'm saying you're missing the diagram and the facts of the problem. Okay. Now, step 2 is what is the question for question 2? And the question is from t equals 0, the beginning of the whole thing, to t equals 8, the end of the whole thing. What is the average velocity? Right? That's what it asks. Now, thank goodness, finally, after all my blithering and blathering and babbling, we're now at a question that actually can prompt. We're now at a question that could finally prompt us to start getting into some symbols here, some symbolic notation. We can start establishing some equations and some math. We can start establishing some equations finally. Like, there isn't technically really an equation or a symbol for average. Oh no, that's not even true. I'm sorry, that's not even true. I know that's not even right. And Paulina was probably shaking her head and I didn't even see it. Sorry. The question is, what's the displacement, right? Okay, sorry, I'm getting ahead of myself. I just so want to get to this, but still, I'm going to start introducing symbols now. What is the total displacement, right? That's the question. Okay, I'm going to get into symbols now due to this. Because as you found out on the very first question, and when you were trying to do this, like, distance is very related to displacement. Yeah, that's okay. Here we go. Oh, everything I'm about to write right now, everything I'm about to write is like class notes. Okay, I'm using this question as an opportunity to move to the side and establish. I'm going to establish some GDPs, some step 3 stuff here. So everything I'm writing right now, I certainly suggest that you do. I'm not saying that you'd have to write all of this in your homework, but I'm establishing this all now for, as a teacher. So first of all, we have this distinction in physics between scalar quantities and vector quantities. Scalar quantities are pure magnitudes, i.e., pure sizes. Whereas vector quantities, a vector quantity, as you may know from other classes, a vector quantity is a quantity or a measurement, with magnitude and direction. So an example of a scalar quantity, as you know, is distance. But a related vector quantity is displacement. And when I say, oh, sorry, that should be. When I say it's related, when I say that displacement is related to distance, what I actually specifically mean is that distance is the magnitude of the quantity known as displacement. Displacement takes into account distance and direction. If I ever tell you a displacement, such as 3 meters to the east, or 9 meters to the south, or for example, I set up a symbolism where negative means south and positive means north or something like that. So I say to you -9 meters, like as in this problem, then I'm telling you a quantity with magnitude and direction. The magnitude of that quantity, the magnitude of the displacement quantity, is what we then know as distance. Distance is the magnitude of displacement. Similarly, we have a thing called average speed. And average speed, by definition, is distance over time. Total distance divided by total time. Now let me pause for a second. I'm saying average speed by definition equals distance over time. Did I mention last class something very important? Did I mention the distinction between triple equal signs and double equal signs? Is that for some reason? I know it's strange.
No.
I'm like putting pressure on Paulina here. Right? Oh, yes. Okay. All right. Awesome. Okay. So great. So the definition of average speed is total distance over total time. Okay. There's an equivalent there. The average speed turns out to be just the magnitude of the vector quantity known as average velocity, which is displacement over time. Like there's a pattern here, is what I'm trying to say. So whenever a quantity is just a pure size, a pure magnitude, or a pure scaling effect, we call it a scalar quantity. It just means it has scale. It just has size. That's all it has. But when it has size and direction, we call it a vector quantity. And for every vector quantity, the sort of size piece of it, or the size aspect of it, becomes known as its own scalar quantity. Now, here's why this all may have already been clear from the top of the sheet or from another class or something like that. But the reason I'm breaking it down like this is I want to admit or say that in physics, ultimately, generally, we're much more interested. We track the vector quantities. We sometimes look at each aspect of the vector quantities, we'll separate them and look at pure sizes and pure directions, but we're really very interested in motion through space and time. And so we very much care not only how much things are moving, but we care where they're moving and what direction they're moving. So we really care about the vector quantities. So I'm going to start developing symbols and equations and stuff that, directly speaking, tend to have to do with the vector quantity. So I'm going to say this. So again, this is all class notes right now. I apologize. Well, it is what these are all class notes. Like, and I guess that's why they're in blue. Maybe, I don't know.
Sorry, Professor. I just have a question on this.
Please, yes, yes.
So this is for the GDP, correct?
Everything I'm saying now is all about the GDP, but it's like a lot of class notes I'm giving you so I can establish a GDP. Like you wouldn't have to write all, it is all for the GDP, yes, but you wouldn't have to write all of this when you're doing your homework. I'm just like explaining some stuff.
I see. And it's can we just like, do you want us to write one GDP per question, or can we just like write one general one for like the entire section?
Oh, that's a good question. Ultimately, in general, I do want one for each question, because the truth of the matter is, once this really starts building all this material and stuff, the truth is you're going to find that each question generally really does have its own different GDP. Like they might all be referring to the same diagram and the same facts, but generally, ultimately, once this gets off the ground, what will distinguish one question from another really is the GDP. And the real sort of hunt and the hard part of how to approach each new question really will be making your decision of what GDP to write down. So I'm going to go a step. So it's a really, really good question. I'm going to go a step further with this. Right. Like, because I know a lot of people are right now sort of just like putting their GDPs at the top and then having them refer through. That is ultimately not going to work as well as it seems like right now. You are going to want an explicit GDP for each question. And the truth is, here's the real truth, is it will turn out that actually a lot of questions will have more than one GDP. That's really when things start getting a little bit more hard, or what we're really trying to prepare for is a lot of questions. Well, I guess I just said it, but a lot of questions will have more than one GDP that you have to put together. And then that's where all the algebra comes in step 4 in PAW. So right now it's all a little bit over much, but yes, please do separate GDPs for each question. And for everybody, it's true right now. Since GDP is like the general concept, or the general definition, or the general principle, or the general law that you need for a question, I'm taking the liberty right now and stepping to the side and developing. I'm right now just developing notation and symbols, letters, so that we can start writing our GDPs as equations. Like we don't have any equations yet. So right now I'm kind of in class notes, but it's all for the sake of developing some GDPs. Does that make sense at all?
Yeah, thank you so much.
Okay, thank you. Great question. Great. Sorry, and since I can't see on this device, tell me your name again. I'm sorry. What's your name?
Alan?
Oh, Alan. You're Alan. Oh, and your last name is Liu. Is that right? Great. Okay. Nice to meet you. Awesome. Great question. Thank you. Okay. All right. Oh yeah, and your homework was great, by the way. Honestly, you could leave it. You're one of those people that you don't have to resubmit it. I mean, you can if you want to be, but your homework was great. I'm just saying. All right. Anyway, okay. All right. So 1D space. Okay. Um. Okay. Again, so yes, this is still class notes here. First of all, I just want to say, so that we're all not just assuming anything. From now on, if I say X, I mean a position. I mean a point in space, in one-dimensional space, a point on what we might call an x-axis. I mean, similarly, if I say y, I mean a point on a y-axis or z or whatever. But I mean that all those are fine. But I mean a point on an axis of space, on a dimension of space. And I should also be clear that right now, everything we're doing right now in physics is we're assuming one dimension of space right now, and we're assuming one dimension of time. We will expand, of course, like the whole world has more than one dimension of space in it, but we're developing the rules and the laws and the patterns and principles for how things work when they move within one dimension of space, on the assumption that once we figure that out, it's like once we understand a brick, we can put a lot of bricks together and then we'll have a brick house like that. So we're building. But anyway, that's what X stands for: a point in space, a position, like one value. Like the guy is standing at X equals 4 meters. That's a place, right? Then T similarly equals a single point in a single point in in time. Specifically a point on a time axis. So T stands for an instant. T right now would be like the equivalent of 12:13 o'clock or something like that. But specifically what we really mean is it's like 12 hours and 13 minutes and 49 seconds from some time that we call zero. So now I have to get to that issue. Okay, now this starts to get possibly in, I'm just looking at the time. Okay. This is partly why the train of thought assignment comes up. Like, let me make this clear. From here on in, we're in one dimension. We're going to have an axis like the number line, like in this homework assignment. Again, I know I'm going off on I'm just like trying to establish some principles here and some notation. But from now on, when you talk about X, you're talking about where you are, what position you're at in relation to some place called zero. We need to establish right now that zero is up to you. It's up to whoever the physicist is, whoever's making the measurements in the experiment, whoever is making the measurements up, who designed a physics problem. Like, I mean, so maybe sometimes it's up to me, but it's up to one of us. It's not up to Mother Nature. There's no objective zero in the universe or in Mother Nature. That's what we're trying to sort of get at with the train of thought thing. It's a choice, but it's not like voting for president. It's a choice, but it's a choice you have no choice but to make. You have to make the choice. You can't not vote. We can't talk about physics or positions or measurements or velocities or anything like that unless we know that we have an established zero. So at the beginning of a problem on a number line or on an axis or on a graph or whatever, some zero is established. It's established clearly. It's part of the labeling that goes on in DFP step 1. And then we have to stay consistent with that zero from then on. So along those lines, okay, again, to some of you, this is like boringly obvious, but to some of you, but we're trying to be consistent in physics and like lay out every we're just trying to be all on the same page. So from here on in, whenever we have a physics problem, somewhere in space is designated 0, somewhere in one dimension of space is designated 0. Everything on one side of that 0 is designated positive. Everything on the other side is designated negative. This enables us to start being mathematical and using shorthand and being more simple in the way that we measure and describe things. Notice that's a complete system right there. As long as you're in one direction, if you're in, one dimension, you only have what we call 1 degree of freedom in physics. If you're in one dimension, you can either go forward or you can go backward, or whether you call it north or south or left or right or east or west, there's only 2 options ever in one dimension. So one we're going to call positive, the other we're going to call negative, and it doesn't matter which is which. It's up to you, or it's up to the guy who designs the problem, or it's up to the person in the lab. But they have to make a choice. And once they make that choice, then they have to stick with it. And so that's, again, part of the labeling system is we make it clear. And we already did in this problem, like it was made clear for you, but we make it clear what's positive and what's negative. Then, and I'm almost done. I know this is like annoying, possibly to Alan, possibly to a lot of people, that I'm still like off the page here, but almost done. There's a lot in the chat. Sorry, I can never see the chat on this device. Hang on. Sorry, I see there's stuff in the chat once. Not what I meant to do. Chat. Sorry. Okay. Okay. What does GDP stand for? But it sounds like there were replies. Oh, that's awesome. Okay, this is all. Yes. Right. GDP is general definitions and principles, and I'm going to refer to them a lot for the next 2 semesters. Like, again. So yeah, but thank you guys for answering. And you already answered. Thank you, Paul, and thank you for saying thank you. So you should all get tons of points for that. But yeah, that's pretty important. And again, often GDPs are triple equal signs. They're often definitions. We're going to be talking about them for the next 2 semesters. A couple distinctions I'm making here. And again, for those of you who are like, get on with it. I mean, I want to get on with it too. I do. But I just want to remind you again, my experience, maybe your experience in high school, my experience is that once physics gets rolling, often, and I would say that we're not really totally rolling yet, but once physics gets rolling, people's experience often is that they say they understand how to do the problems when, like, someone goes over them in class. They even sometimes understand them sometimes when they're doing them or when they're doing with friends, whatever. But often people will say, I understand how to do physics problems, but I don't know how to start them. I don't know how to set them up. Like, once you tell me what people will say, once you tell me what formula to use, then I can do the problem. So what I'm really here to say is, right, that is such a common concern, I'm so sympathetic to it in a way. But in another way, what I'm really here to say is, yeah, but that is the physics. Like, once someone gives you a formula and then you can go, that means that what you're good at, ironically, is the mathematical computation, which is what everybody thinks they're going to be scared of when they come to physics. Most people actually can handle the mathematical computation if they've gotten this far. The physics is in knowing how to set up the problem and setting up what math you need to do in order to do it. So we spend a lot of time emphasizing these GDPs because the GDP is the hard step. It's like, what do I need to know to do this? Not what do I need to know from the problem itself, but what do I need to know from the universe? What general truths will be helpful in this specific situation? That's the hard part of physics. So again, and I'm being defensive, like, I'm apologizing if I'm spending too long on it, but I actually think that's what people need the most work on ultimately. Well, so I'll leave it at that. But yeah, so I'm glad people are at. So there's never any shame in you bringing me back to it. I am apologizing because I don't want to bore anybody or get stuck. But GDPs are really worth thinking about. And that's where I'm going to go back. Okay, and now these captions are on. I don't know how to get these captions off. Okay. So now, what does time equal 0? this is actually a slightly more interesting question than what is x equals 0. And we're going to need this for notation in a minute. What do we need? What do we mean when we say time equals 0? Well, I mean, that could be very deep, right? If you interpret it the wrong way. I mean, but we're not trying to be deep. We don't mean the Big Bang when we say time equals 0. And we don't mean the Garden of Eden when we say time equals 0. We don't mean the beginning of everything. We don't mean the beginning of time. We mean the time beginning of the experiment or of the situation, of the problem. What we really mean by time equals 0 is when what we literally mean is when the stopwatch started. And I mean that honestly. Like the minute you say go and you start your step, so it really means the minute you start paying attention. And that's an important thing to, so first of all, it's totally up to you. Just like x equals 0 is up to you, it is up to you. So you make a choice that's going to be convenient for the rest of the problem solving. And then you stick with it. And it really means that the way we view physics experiments or the way we view physics situations is we actually think of them as things that are just going on and on and on all the time. And then we walk in and start paying attention at a certain moment. And the moment we start paying attention and start taking measurements and start tracking, we start our stopwatch. That's now called t equals 0. It's when we started recording data. Okay, for whatever it's worth. So now we're almost back to the problem. I want to give you a couple more pieces of notation now, though. So now you know what we mean by x, what we mean by t, and x and t are all values that are measured in comparison to or relative. Okay, so in short, okay, so just to summarize, right, all x values and all t values are measured relative to some base that we call 0. They're all, in effect, comparisons, right? So therefore, we have this new piece of notation that we use. Thus, okay, on the next page, I'm going to tell you that this is general. In general now, if you ever put down any variable that we have going on, right now we only have 2 of them, but any variable that you ever write down, if you put a 0 subscript to the right of it, we read that out loud so in this example, the variable is x, we would read x sub 0, we would read it out loud as x naught. And naught means nothing, like in British or something. And there's 2 different ways to spell it, but whatever. So x naught is how we would read that out loud, and it doesn't mean 0. It does x naught, in fact, note. What x naught means is whatever the value of x is at time equals 0. Okay, and from now on, if we have any symbol at all, and I can go back a page if you want in a second, if I have any symbol at all from now on, any new variable like v or a or something, then if I use this, then that symbol with the subscript next to it means the value of that symbol when t equals 0, always. Okay, so squiggle naught means the value of squiggle when t equals 0. Therefore, according to this, T naught necessarily means value, it means T naught Now, T is a variable. T is a symbol. So according to this pattern, if we write T naught, we mean the value of T when T equals 0, right? Because it's always about the value of whatever when time equals 0. So in the special case of time, if we write T naught, then T naught necessarily does equal 0. Right? T is special because of the definition. So from now on, if we ever write T naught, the value of T when T is 0 is by definition 0. So that we'll be able to cross out in equations and stuff like that when it comes up. All right, well, I'm just looking at the time. Okay, 1:16. All right. So one last thing then, with this notation. Okay. We don't, from now on, if you ever see X minus X naught, that is a symbol for the English word displacement. So I did all of this again and again. I it's kind of boring, I know, but I did, and it's maybe confusing because I'm off the page. But all of what I just did is in an attempt to start translating our English terms into mathematical symbols. So our first so a given position is known as X. The very first position is known. Okay, actually, I'll add a step. Hold on a second. So what I'm saying is displacement. Notice I'm going straight to displacement. I'm not talking about distance. I'm talking about displacement, which brings us finally back to question 2. Displacement is literally how far we were displaced in a particular direction. It means how far we got in a particular direction, how much our space was changed, how much we were displaced, how much we moved from one place to another in a particular direction. So what it really is the difference between where we are now and where we were then. Like literally that's what displacement is, right? Displacement is the difference between some position, call it now, versus some earlier position, call it the initial position. And the thing is, I can be that general in saying that because what you call now or what you call the first position or what you call the initial position is all up to you, right? That's why I sort of took pains to establish that what X naught is up to us. We can start tracking measurements wherever is convenient for us. We can etc. So what displacement is the difference between two positions. You could call them position A and position B, or you could call them position initial and position final, as they do in some textbooks. But the most general, fast thing to call them is just a position X and an earlier initial position X naught. So from now on, whenever anybody asks me about displacement, I'm going to think about X minus x naught. Just note one last thing. I'm looking at the time. Okay. Just note, because this is going to be important in physics too, just note x is a point. It's a value of a point in space, just like t is a point. It's a value of a point in time. But x minus x naught is now an interval, a segment, a separation, a comparison between 2 points. Like that's going to be a big, in physics, a lot of things we look at are individual points. And a lot of times we look at intervals between points. Quick note on that, if you're taking notes or if you're like, the truth of the matter is looking at individual points gives us more precision, but it's also much more, it gives us more theoretical precision, but it's much more difficult to physically measure or mentally relate to. Like honestly, like individual points are more theoretically precise, but they are harder to actually picture or measure. Intervals are easier to measure and to picture and hold in our minds, but they're more approximate. And that's like a balancing act we always have to do in physics. But so okay, so now finally I can get back to question 2. Okay, remember I originally said we were going to finish this today. Oh my god. All right. Well, anyway, so question 2. Back to question 2. Oh, I'll do this in black. Back to question 2, for the sake of Alan's very fair question and everybody else. Back to question 2, I would say that the step 3 GDP is just what I just wrote down. Displacement equals x minus x naught. Right, so it wanted to know the displacement of the whole 8-second journey. So now I do step 4, PAW, particular application and work. Remember, we're trying to go from general to particular always. Well, anyway. And so we say, so I would say something like here, X, the very final position of the entire journey, the very final position where he ended up, I believe, was -5 feet. Correct me if I'm wrong. And the initial position was +4 feet, right? So the displacement is literally -5 minus 4, right? So you have to, it literally is a minus sign because it's a difference. It's like if I, and it might even feel like it's going backwards, like you are sort of going backwards. Like you're plugging in the most recent thing first and then the earliest thing second. Why? Well, the same reason if I said to you, hey, how much, oh my God, I haven't seen you in a year. You've grown so much. I feel like you've grown like 3 inches. Then you would be like, well, let's see. I'm 5'8" now, and I was 5'5" then. So 5'8" more. See, this is from the shop, this device. Oh my God, hold on. I have to get back to, I don't know if I'm still on Zoom even. Are we still in Zoom?
Yeah, you're still on Zoom. You're still here.
Oh, good. Okay, thank you. All right, good. I can't see it, but good. Okay. And you can still see the board or no? Can you
Yeah, we can see it still.
Okay, good. All right. I don't know. I'm losing my mind. But all right, cool. So, and I know we're almost done also. So basically, right, like if someone was like, how much did you grow? You'd be like, I am now 5'8". I was 5'5". So I subtract then from now and I get 3 inches. I grew 3 inches, right? You are actually doing the calculation backward in time. If you think I'm not trying to confuse you, but right, it's the same thing here. So you literally do minus signs. You put in you literally do subtraction. You put in minus signs wherever they belong. And you get -9. So then for the last step, and I'm sorry, I'm just doing this blindly. If you can see me, that's great, because I'm just talking to a wall here. All right. So then for step 5, and this is what we were talking about before, you would literally write out, okay, from t equals 0 to t equals 8 seconds, x minus x naught equals -9 feet. Like, that's your answer. And this is the thing that I'm a little bit picky about with people. Like, notice the final answer is literally an equation. It's not a formula. I don't like the word. I never use the word formula in physics, actually. What I mean is, this is not an equation that you're going to memorize and use in any other context, but it is an equation. It's saying two things are equal to each other. It's a complete thought. It's got a subject and a verb. Okay, it's 1:26. Let me see if I can quickly do one more. I gotta somehow get back to, how can I? Are we back? Oh my God. Okay, we're back. And I'm just looking if there's nothing in the chat, right? Okay. All right. You know what I'm going to do now to move along? That's how to do the 5-step method. I think it's sort of clear to people. I'm going to skip a little bit right now just so you can get some more satisfaction. I'm just going to say for question like 3 and 4, I'm just going to give some answers now for some satisfaction. We'll go back and develop more maybe next time, but answer for question 3, it asks for the average speed. So we don't have average speed is English. The GDP would be average speed, triple equal sign, distance over time. There's no like math thing to write for that. There's just English, but that's what you would write. And the answer you would get, the answer you would get for question 3 is 21 feet over 8 seconds. You can leave it like that. It's totally fine. You can turn it into a decimal like 2.625 or whatever. That's totally fine too, or whatever it is. That's fine. But then we get to but that's the answer. Then we get to question 4. Okay, the GDP for question 4, and we're going to end with this. I'm sure. Yeah, we have 2 minutes. Okay, for question 4. Again, I'm just doing answers. I'm not doing all the steps right now, but the GDP for question 4 is that average velocity from here on in. The average velocity is defined from here on in to be displacement over time. Let me pause on that for 1 second. Well, I'll get the answer, fine. So the answer here, to skip to the final answer circled for this will be that the average velocity is -9 feet per 8 seconds, or you can write it as, -1.125 feet per second. Either one is fine. And that's from t equals 0 to t equals 8. But one thing I want you to note for the future, and then we're going to end right here, is from here on, any measurement with a bar over it, means the average value for that quantity. Like V with a line over it means average velocity. And this necessarily always applies to an interval, not to a point. Like, you can compute the average velocity from here to there, you can't compute the average velocity at here. So average velocity is displacement over time. And last thing I'm really going to say, you'll notice if you've done, well, you notice when you get to homework 2, in the last 2 questions, the big thrust of homework 2 is that the definition of average velocity is displacement per time. The definition of average speed is distance per time. Since those are definitions, they're never wrong. Sometimes they seem hard to use, maybe, but they're never wrong. They're always right. Anything else is not right. Like what I'm really trying to say here as loudly as I can, especially for homework 2, is the average velocity from here to there is not the average of all of the velocities from here to there. That's not what it means. We're going to discuss this big time next class, but the average is literally, the average velocity is literally the displacement over the time. And last thing, where some people went a little bit wrong in parts 2 and 3 of the homework, of this homework, is if you have the average for the whole thing, like -9/8, we just got, that's the average for the whole complicated journey. There's no reason to believe that that's the average for each segment of the journey, right? Your average at the end of a class is not necessarily the same thing that you got on every single exam on the class. You're building, like your average changes all the time, right? So for a lot of people, for part 2 and part 3, when you were trying to figure out where, or I think it was part 3, when you're trying to figure out where is the instructor at t=7, you have to be a little bit more, that's where it gets hard. You have to be a little bit more thoughtful than just plugging in the average that you got for the whole thing, because the average changes for the 3 different segments. Okay, I'll leave it at that. I know this was a disjointed class. I apologize. I'm stopping. I'm going to stop the recording. You can definitely go. I will see you on Monday, and I'll answer questions by text. But I'm here until the last person leaves. Like if you want to ask questions, I'm totally here. But I'm going to stop the recording, and thank you very much. Yeah. See you for a more normal class on Monday, I hope. Thank you guys. All right, I'm stopping the recording. Okay, have a nice day. Yes.